Have you ever wondered what happens when a complex, natural world, one that's been built over millions of years, collides with a simplified, human-made one? Well, that's exactly what we're looking at today, a real ecosystem showdown.
So here's how we're going to break this all down. First, we'll get into the rainforest's incredible complexity. Then we'll switch gears to the oil palm system. After that, we'll put them side by side, see who the winners and losers are, and finally ask what happens when you pull a key piece out of the whole puzzle.
All right, first up, let's dive into the rainforest's complex web. And I want you to try and picture this. Don't just think of it as a bunch of trees. Think of it more like a massive, bustling city, just humming with life.
Wow, just take a look at this. You're looking at what's called the understory. It's this super dense layer of smaller trees, shrubs, ferns, you name it. But it's not just a random mess of plants, It's more like a purpose-built neighborhood offering shelter and a home to so many different animals.
And get this, that's just one level. The whole rainforest is built vertically, kind of like a living skyscraper. Way, way up top, you've got the emergent layer, where giant trees poke out into the sunlight. Then you drop down into the canopy, which is like a highway for monkeys and birds. Below that is the understory we just saw. And finally, you hit the dark, moist forest floor. Each layer is its own world.
So you take all these layers, all these plants and animals, and all the ways they interact with each other and with their physical environment, well, that whole package is what scientists call an ecosystem. It's really just a community where everything is connected to everything else.
Okay, so here's the key takeaway. In a system that's this complex, with thousands of species all fighting for food and space, no single group can just take over. The competition itself keeps populations stable. It's like it has its own built-in system of checks and balances.
And this is a perfect example of that balance in action. You've got predators like the incredible Sumatran tiger, and they hunt prey, like wild pigs. It's this constant dance, this push and pull, that creates a really stable food web and stops any one population from just exploding.
Okay, now we're going to do a complete 180. We're leaving that bustling, complex city behind and stepping into the oil palm system. And believe me, it's a completely different world. Way more uniform, way more simplified.
And you can see the difference right away, can't you? It's so stark. This is what's called a monoculture. All that diversity, the thousands of plants, the different layers, it's all gone. Instead, you just have these neat, endless rows of one single crop.
So what happens in a system this simple? Well, with way fewer species and not much competition, some animals basically hit the jackpot. They find a nearly unlimited food supply. And that can cause their populations to just boom. And the predators that eat them, their populations can explode too. It's like the natural brakes on the system have been totally removed.
All right, so we've got these two totally different worlds. It's time to put them side by side and really dig into what makes each one tick. Let's break down the differences.
This table really lays it all out, doesn't it? I mean, look at biodiversity. You go from thousands of species in the rainforest down to just a handful. Vertical layers? From 4 distinct zones down to basically 1. The variety of food plummets from super high to super low. And the result of all that, competition and interaction just crater.
Okay, so we know the systems are different. But what does that actually mean for the animals living there? This is where we get to the real-world consequences. Who are the winners, and who are the losers in this new setup?
Let's start with a loser, unfortunately, the clouded leopard. This cat is a specialist. It's an ambush predator, and it needs that dense understory for camouflage. That's its whole hunting strategy. So when you clear that away for neat rows of palm trees, you take away its home and its hunting ground. It's no surprise its population is dropping.
But then you've got the generalists, the survivors, like a lot of snakes. These guys are super adaptable. They can live in trees, hide in shrubs, a complex forest, a simple one. They can kind of make it work. Their needs just aren't as specific, so their populations tend to hold steady.
And then you have the big winners, the opportunists. Think rats. For them, these simplified areas are a paradise. There's tons of easy-to-get fruit and insects, and a lot of their old predators are gone. So what happens? Their populations are actually increasing. They're thriving.
All right, for our last piece here, I want to zoom in on something really important. What happens when you pull just one single piece out of this complex machine? What happens to a system when it's missing a key?
This is the orangutan, and it has a job that almost no one else can do. It's one of the very few animals strong enough to break open and eat these really big, hard-shelled fruits. And in doing that, it becomes a crucial seed spreader for those specific trees. It's a specialist with a vital role
And sadly, its population is also on the decline.
And really, this brings us full circle, back to the central idea of this whole thing. It boils down to this. The rainforest system has way more components and way more interactions than the oil palm system. That complexity isn't just a fun fact. It's the very thing that makes the rainforest so stable and so resilient.
So I want to leave you with this question. The orangutan is just one piece of this giant interconnected puzzle, right? But it's a unique piece. It's a key. So what happens to the whole system if you lose that key? What other dominoes start to fall throughout the forest when it's gone for good?